distribution here on the board. You can see we still have distribution on the board. So let us pick it up. I think we are moving. And D is what we have here. Our N. So this is the procedure. N is 870, N over 2, and is substituted. It was N we are looking for that we do not know. The cross multiply, they multiply out through by 2. The 2 multiply this one is this. Just like same procedure. And if you simplify this is this. In our 2. 27 plus 3N here. So, and they actually expand and they bring this, they expand this is this, they now bring this to the other side. So everything equals to 0, and they divide this out by 3, just like exactly what we did. They look for 2 factors and N is 20. So I hope we understand. Now, second example, which is now, we're now moving to the world of finance much more. Because as far as finance is concerned, it is one that was like sequentials. Now, arithmetic, like, there are arithmetic, some are arithmetic, some are what are geometric words in nature. That's whatever you define the balance of finance. So, let me write this off quickly. So, the next information here is this. Mr. Emeka earned 240 per annum with an annual first term increment of 25%. So that means the amount you earn is the first term. The first term increment is the common word difference. This first amount is earning. So that will be our first term. And every year, annual increment. After every year, 1 year, it should be increasing by. So that is our common difference. It's positive. Now, one month will you earn in its 8th salary? So you are looking in the 8th year. You are looking for the 8th term. If A is 240,000 and G is 25,000, then how much will you be collecting in the 8th year? So find the 8th term. So that will be 8 plus 7G. You know that? Yes. So that will be equal to 240,000 naira plus 7 times D. What is D? D is 25,000. So we have 240,000 naira plus 7 times 25,000. What is 7 times 25,000? 7 times 25,000 give us 475,000. And all B is pay. So his pay is plus 240. He's collecting 415,000. In his 8th year. That will be his pay in his 8th year. What will be his monthly salary during the 15th year? So we get the annual salary first, because let's get the 15th term, we now divide by 12. So 15th term. So 15th term will be B now, the 15th term will be 8 plus 14D. Let's get the amount to be collected in the 15th year. That will be 240,000 the first term plus 14 times 25,000 naira. So we get this. It's AP because it's incremental. We are adding. It's out every year. So each year at the first term. So we say his pay will be 14 times. The first year will be 240 will be his pay. Second year it will be increasing. Third year it will increase also for 25. So plus 350. 14 times 25,000 is 350,000. So his pay now will now be 590,000 in the 15th year. Monthly pay now. This is the annual pay in the 15th year. So monthly salary now or pay is equal to 590 divided by 12. So we divide that by 12. And we have 49,167 approximately. 467. So that is his monthly pay. If we retire after 30 years and his gratuity is 2,000 his annual salary, how much will we pay as gratuity? So let's get his annual salary in 30 years. So now you are looking for T30. What will be the T30? So T30 will be will be A plus 29D. So we have A is 240,000 plus 29 times, what is our D? D is actually 25,000. So we have 240,000 plus, what is 29 times 25,000? 29 times 25,000. So we have 725,000. So we have plus 240. That would be 965,000. So this is his pay. His gratuity is now what? His gratuity is 250% of his pay of 965,000. And that will give us what? So that will give us 2,412,500. So this guy is gratuity. I 250% is 250 divided by 100 times 965, and that will give him that. So this is gratuity. Is that percentage of his pay in the 30th year, and this will be the expected pay in the 30th year. So it's new pay. Some companies apply that they follow that manner in determining the pay of the employee. How it should be changing every year, the adjustment, and irrespective of what happened, the pay will remain constant. So that is that. I think we have the same thing. We have the same thing, as you can see. We have the same thing. So next question now, what does it say? GP. GP has been explained. Geometric progression is how we are multiplying and to get from different term. So let's see for example on GP. This is sum of GP. When R is less than 1, we use this. Remember, I corrected myself. Greater than 1, we use that. So sum to infinity of GP. I'm sorry. If our n is very large and R is small, maybe R is less than 1. Our n is very large. What will happen? This R is for n is 0. That means n is summing to what? Our n is closing to infinity. So our sum to infinity is always A over 1 minus R. Again, sum to infinity is what? A divided by what? 1 minus what? R. Don't forget. This converts now to this. So A over 1 minus R. That is sum to infinity. Let's take an example now. Example. Find the seventh term of the GP. 816 and 2. So we have to get the seventh term of the what? Of the GP, of the geometric progression. So this is what we're going to do. We'll say, what is the first term? A is 8. What is R? 16 over, there is second term over first term, or you can say third term over second. That is 2. So we have to get the seventh term. Our T7 is equal to A R n minus 1, which is 8 multiplied by in bracket. Common ratio is 2 raised power 7 minus 1. Next time I will write it as A R raised power 6. Yes, 7 minus. So A R raised power 6 is the 7th time. Next time. So pay attention. So I will say 8 R is 2 raised power 6. Can you see when I subtract 2? So it's still this. So what is 2 raised power 6? Everybody knows that 2 raised power 6 is 64. What is 8 times 64? So 8 times 64 will give us what? 8 multiplied by 64 gives 512. So that is the 7th time. 512. Now this said find the 6th term of GP. So what is the GP? The first term of the GP is 243. So the common ratio of the GP R is 81 over 243. Or we can say 727 divided by 81. 81 here is 1. 81 here is actually 3. 27 here 1. 27 here is 3. So 1 over 3 is the common ratio. And we are looking for the 6th term. So our T6 will be A r raised to the power 5. I still apply this formula. I told you. That will be r raised to the power 6 minus 1, that is 5. So we'll say our first term is 243 multiplied by 1 over 3 raised to the power 5. So we say 243 multiplied by 1 raised to the power 5 is 1. 3 raised to the power 5 is 243. And we have 1. The sixth term is 1. The sixth term is what? Is 1. Now, the next one said, find the sum of the first 15 terms of the GP in A and B. So in A, I'm looking for S15. Our Sn is what? What is our R? Our R is 2, greater than 1. So it's better we use A, open bracket, R raised to our N minus 1, all over R minus 1. So I will now say S15 is equals to 8, which is the first term, multiplied by 2 raised to our 15 minus 1 all over 2 minus 1. So we have, what is 2 raised to our 15? I will subtract 1, I will multiply by 8 and divide by 1. This is 1. 2 minus 1 is 1. So I will say I have 2 raised to the power 15, come down, minus 1. So that gives me 32,767. So 32,2 raised to the power 15, 767. So 32,767 times 8 divided by 1. Everything here is 1. And that will give us 262,136. So this is some of the first 15 terms of this. That is the answer C. Now of this one. So the sum towards sum of the first 15 terms. What is our R? Our R is less than 1. What about 3 is less than 1? So we use what? Our Sn, we use this formula. Sn, that will be A multiplied by 1 minus Rn over 1 minus R. So our S15 will be equals to, first term is 243, 1 minus 1 over 3 raised to the power 15. 1 over 3 raised to the power 15 over 1 minus 1 over 3. That will be equals to us. So I think you can do this. If you finish that up, you are a mathematician. Raise it to 1 over 3 raised to the power 15. Subtract the answer from 1. Multiply by 2.3. Subtract 1 over 3 from 1. Then divide. Or you put that into a natural calculator. Some of us are not good with number like that. If I were you, just put it exactly into a natural calculator and you will have your answer. Yes, you have your answer. So I'm pressing that now. 243. No, open bracket 1 minus. So we have 1 over 3 raised to the power 15. So I will come down, close that, then divide by 1 minus 1 over 3. And that gives us 364 points. That is the, so that is our answer. So we have that as our answer. Now the last one says, find the sum to infinity for A and B. Sum to infinity. Let's do that. We use the board. We use the integral board to solve that. So I don't want to rub out the question. So sum to infinity. For the first one, let's divide the board. For the first one, our A is our sum to infinity is given as A over 1 minus R. So for the first, A is 8 over 1 minus. No, sum to infinity for the first one is not possible because R is not less than 1. So is that okay? So minus 2. So sum to infinity altogether is actually minus 8. So they will say not realistic. So not realistic. So nobody gets sum to infinity in a sequence like r is greater than 1. Yes, it's not realistic. So, not realistic. Now, sum to the infinity for the second one is correct here because r is less than 1. So we have 243 divided by what? Divided by 1 minus 1 over 3. So we have 243 divided by 1 minus 1 over 3 will give me 2 over 3. That's what it means. So I will now have 243 times, I will find the reciprocal of this. That will be 3 over 2. And that will give me what? That will actually give us, let me see what it will give me. So I will say 243 times 3 divided by 2. That will give me 364.5. So it's similar to what we did earlier. Exactly the same. That means the existing term is almost sum to what? To infinity itself. So the difference there will not be significant. So it's still the same thing. So that is all. Sum to infinity of the two is this. But sum to infinity here is very realistic. It's not possible. So here, in the second one, it's possible. Why is this one is that not realistic? Because r is greater than 1 than 1. You don't get sum to infinity when r is greater than 1. Is that okay? So that's why I try to understand that. So what is the solution? Let's see. So our sum of the first 8 term in that 7th term in that is 512. You can see on the board. Sum of the 7th term here is 1. You can see on the board. Okay. CI. Some of the first 15 term of it is 262, 136, same thing. Some here is 264.5, same thing. Okay. Something this is not possible since r is greater than what? Than 1. You can see I even solved that. So it's rubbish. It can't be -8. So I shouldn't have solved. So it's rubbish. So for here it's possible. So it gives me what? It gives us 25.1.5. So it's convergent to that. So it's very close to that. So next thing now we have to move to now is another example, which is now becoming complex. It's getting complicated. Yeah, it's getting more complicated. I hope we'll be able to follow. Yeah, it's getting more complicated. So here we have another example to actually consider together. And what does the example say? The example says a job is estimated to take 12 days. It takes maybe 12 days. If the overhead costs were 5,000 like that for the first day, 7,500 for the second day, 11,250 for the third day, and so on. How much will be total overhead? It's taking 12 days. Now look at the pay for the first day is 5,000. For the second day is 7,500. For the third day is what? 11,250. Is that AP or GP? So my first term is 5,000. Second term is 7,500. If it's AP, my common difference will be 7,500 minus 5,000. That is 2,500. Third day is this. Is the difference between 11,250 minus 7,525? If it is this, it is AP. If I supply 11,250 minus 7,500, hey, it didn't give me the common difference that which 7,500 minus 2,500 gave me, so it is not AP. So if you have two different ways of getting your words or common difference, it should always be the same. So since 7,500 minus 5,000 is not the same as 11,250 minus what? 7,500. It's telling you it's not AP. Yeah, let's check GP. What is the ratio? Is it GP? Let's check. Our common ratio here would be, what I did, I did, D must equal 7,500 minus 5,000. That is second minus first, or that must always be equal to 11 to the third term minus second, and that is not equal. So D is not equal to like that. So the first is wrong. Now our R is second term divided by third term divided by first term, or third term divided by second term. Is it the same thing? If it is, that means the GP. Let's see that. What is 7,500 divided by 5,000? 7,500 divided by 5,000 is 1.5. What is 11,250 divided by 7,500? We've got the same ratio. So it's GP. Now we are asked to get how much total variable cost. We are paying each for each day, and the amount is progressing like that. So how much are you going to, what will be your total variable cost? So we get sum of the first 12 term. If the first term is 5,000 and the cover ratio is 1.5, what will be the sum of the first 12 term to get the variable cost? Let's get that. Sum of the first 12 n term of an AP. A is r is greater than 1. That will be A times r raised by m minus 1 over r minus 1. So we have sum of the first 12 term equals to, first term is 5,000 times r raised power r 1.5 raised power n. N is what? N is actually 12 minus 1 divided by 1.5 minus 1. So we say sum of the first 12 terms is equals to 5,000 times, what is 1.5 raised to power 12? You subtract 1. So 1.5 to the power of 12 is 129.75 minus 1 divided by 0.5. So we have, we have 129 minus 1, that would be 128.75, that's subtract 1 times 5,000. Yes, here is 0.5. If I subtract 1, 0.5. So divided by, so I have 743,750, 723,750 divided by 0.5, and I have 1 million. That's much. 1,287,500. That is all. That will be total variance. All the value you pay from the table. So that is total variance you pay. So that is our A. A has been done. B, the swamp in a village is highly infested by tsetse flies. After a lot of appeals by the head of the village, the state government took necessary action, and the population of the flies started to decrease at a constant rate of 20%. Yes, it means if their population is certain amount, it will decrease to 80% in a period. By the time it will decrease again, it will decrease to 80%. Because it's decreasing by 20. So but our common ratio there is 80, not 20. What it decreased to, that's what concerns us. So although the rate of decrement is 20 but what it decreased to is what concerns us. Is that okay? That is our common ratio. So common ratio is 80%, guys. Now if at the initial stage they were 1.4 million flies, that is our first term. How long will it take to reach population flies to what? 30 million. That means this is the last term. Okay, this is like TN. We don't know what that term is. How long is not the term? Is that okay? So we are saying in that question, let's just write information here. So I'm saying my first term is 104 million. Yes. My common ratio is 80%, 0.8 is 80%. It will reduce to 80% every time. In every 3 years, it will be reducing 0 per annum. In the first year, it will reduce to 80. Whatever it will reduce to is for the first year, by second year, it will reduce also by until to 80 again. It will reduce like that. So in what year now will now be like TN now will be by in some years time, which is N, to be by to 30 times that term TN. So what is now N? What term is that? Will it be 30 million if you continue to decrease at that constant rate? So it's those three information are what we need. Let's use them. So this is what we'll do. We'll say our TN normally is N minus 1. So my TN in the particular term is 30 million equals to, my first term is 104 million multiplied by R. My R is 0.8 raised by N minus 1. This is N. Raised by N minus 1. So I will divide both sides by 104 million. So if I divide both sides, we have 30 million over 104 million equals to 104 million times 0.8 n minus 1 over 104 million. So this we cancel this. So million we cancel million. What is 30 divided by 104? Let's make life easier for ourselves. So 30 divided by 104 is Jesus. It's 0. Let's approximate 0.2885. So this part equals to, there is 0, we made 0.8, this for n minus 1. This for n minus 1. So here, I will take log of both sides. That will be log. You have to introduce log. I'm sorry, you have to introduce log of 0.2885. You have to use your calculator. This part equals to log of 0.8 raised to n minus 1. So we have log of 0.228 is what? Let me check. So I can, in logarithm, we have a rule in logarithm that says if you have a log of this to the power will be a product of the overall log. So what I have here now will be n minus 1. The 2 multiplied by log 0.8. And that will be log 0.2885. So if I make n minus 1 into the formula, I will divide both sides by log 0.8. So that will be log of log. Let's use the normal log. So we are transitioning from there to continuation. This is A, which is done already. So we can this from there. So that will give us, so we are just saying we have, we divide this out by log 0.8, that will be log, what we have at the left hand side, 0.2885 over log 8, that is 0.8, equals to log 0.8 divided by log 0.8 there, we have n minus 1 here. So let's divide log 0.865 divided by log that. What is that going to give me? So you can use a calculator. Log 0.2885, close bracket. You close bracket first too. Yeah, some of you don't know how to use calculator. Divided by log 0.8, then close the brackets. That gives me 5.571 equals to m minus 1. I'll move m minus 1 to this side. And 5.571 plus 1 equals to 1. And we have 6.571 equals to 1. So n is approximately 7. So in 7 years' time, the population will reduce to that. Or almost 7 years' time, it will reduce to that. So that is the answer. That is the answer. So because 7 is second, and we got 1 multiplied by 7, 500 in the first. So I think you can see almost the same thing. I have admitted in mind, that is right. So in the second, our n is what? Is 6.757. Almost the same thing. So I think we are good. Next question. There's no time to waste time at all. So a businessman realized that the return from his business are breathing, that is losing, due to economic what inflation. He decided to be saving some amount of money every month, which follows the dividend returns as follows. The first one is 240,000, 960, 3,000, 30,400. Is that AP or GP? I think 96,000 minus 240,000 can never be 28,400 minus this. So let's take GP. Let's confirm 2 GP. So if 2 GP, can it be GP? I know it's not AP because common difference is not the same thing on both sides. That is what you used to know. So if you don't know what that sequence is, you need to confirm. Because the formula differs in each area, so you need to confirm what it is before you start to solve. You don't just jump to solve, or else you miss it. So if you jump to solve, you miss it. So you need to check first what is actually represented before you start to solve. So our common ratio now is, if you say now it's 96,000, second term divided by first term, you see the same thing as third term divided by second term in ratio. So that's our common ratio. I know the same thing, let's confirm. So we'll say, we will say something to the GP actually. I don't need to bother myself. So this is 0.4. The second one call is 0.4 divided by 6,000. So we have 0.4 in both. So we are class with family is total savings in 16 months. Yes, in 16 months. Is it monthly because every month, so it's monthly. For the first 3 months, we have that. So what is the total savings is 16 months. The total savings is 16 months. We are talking about sum. It's taking that every month. So it's saving that every month, but it's reducing. So what is now the total saving in 16 months? We are talking about sum. So we are looking at some of the first N16 term. So our Sn, n is less than 1. So we are using a 1 minus r is power n over 1 minus n. So S16 will be equals to, first term is 240,000, that is a, 240,000 multiplied by 1 minus the 0.4 is power n is 16 over 1 minus 0.4. So we have 240,000. 1 minus, what is 0.4 is by 16? So let's see that 0.4 is by 16 is it's actually 0.00002495 over 0.6. So let's do that please. So I will say 1 minus that. So obviously I have 1 minus 0.000492495 times 240,000. If you can use the calculator, divided by 0.6. That gives me 999.9. And I'm calculating 400,000. Yeah. That will be total savings in the numbers. And 2 over 5 is 0.4. So that is total savings. What is the sum to infinity? Sum to infinity will be, is that okay? Sum to infinity is a over 1 minus r. So it's possible, it's less than that. So the a is 240,000 divided by 0.1 minus 0.4. That will be 240,000 divided by 0.6. So we have 240,000 divided by 0.6. And we have 400,000. So it's converged to this. So this sum to infinity, so as it's becoming large, to convert, because the addition there in later years will come to maybe term, since it's less than that. So what is going to happen later terms here after the 16th term is insignificant. So that is converged. So that's what you asked us to explain. Compared to this one, they are almost the same thing because the sum to infinity converged to that term. Like what is adding after the 16th term is not there, what they are insignificant, so it's converged. So that is what that is. So that is information you will give me what in B. You have to compare your side I and I. So we've done. So we have this very close, you can see. I have presented mine to 400,000 euros actually. So that's what I got. So they combine actually. Next question now. Next question. I think we are now getting to finance. Can you see that we are now moving to finance? We are still applying GP, but it's now related to money works. Savings, is that okay? Expecting returns, salaries. So we are still using our GP. So any one of you that have a very sound knowledge of what of mathematics, you will actually find it difficult. Is that okay to understand all what these are? So being as someone who are versatile with mathematics, operations, equations, you can't be any issue. So now next one is that an investment is estimated to grow at a rate of 15% per annum. So the next one is that alright, so we have another example here that says an investment is estimated to grow at a rate of 15% per annum. It's going higher. So but that means in the first period it increased by 15%. That means it will amount to what we have before. What we are going to have now, after the previous will be 115%. So when we did 20% decline, step flights, we said the rate of decline is 20%. Our common ratio is 80 because it was green, it was falling. But this one is now increasing by 50. So that means if it's a full percentage before, by the time it will reduce by 50, it will become 115%. So our common ratio is 115%, which is 1.15. Is that okay? So if the worth of the investment now is first term, what will it worth in the sixth year? Now we're looking for the worth for the sixth term. Yeah, we're looking for the sixth term. So we'll just say, let me just drop this one off in the board. So just say my first term is 250,000 naira. So my common ratio is 1.15. I brought it at 50% plus 115, but it's increasing, not falling. 15% is not the common ratio, don't miss it up. So what will be the words in the sixth year? My link for the sixth term. So Tn is AR is per n minus 1. So T6 is equals to AR raised to power 5, 6 minus 1, good. Next time, I'm going to write that straight. Next time, I have 850,000 naira, open brackets, 850,000 naira, open brackets, 1.15 raised to power 5. So we have what over there. So 1.15. So 1.15 raised to power 5. Times 850. So we have 1,709,653.62. So that is the salary in the sixth term. Being an analyst, we are doing the GP. What is the divided increase in the fourth after 6 years? It's what is this? In the sixth year, it was this before. So what can it increase? We said the new, so diluted increase is the new minus the old over old times 100 over 1. So what will I say? So I'm saying diluted increase there is going to be that will actually give me 1,965,361. So that will give me 1.1, is that okay? 1 percentage. So 1.14%. That is a very good one. It has increased sharply. In what year will the investment worth 3.28 million? So we are looking for C, our TN is actually 3.28 million. If we are 3.28 million, that would be 280,000. Let's write that in full. So what here will that be that amount? So what here is that? So let's use the board to solve that. Let's apply the digital board. So we have our A to base 50, common is 1.15. Tn is that. So what is our n? Yes. So say Tn is actually n minus 1. So our Tn is 3,280,000 equals to 850, which is A. Our R 1.15. Then n minus 1. So let's take log. Let's do that by 850. So 328,000 over 850,000 equals to, if we divide it by 850, we have 1.15 this power n minus 1. So this now divided by 850 will give us what? So we have what? So that gives us 3.8588 equals to, if you take log of we have equals to 1.15. Let me calculate that. I'm not looking at it. So 1.15 this power n minus 1. So this n minus 1 is going to see. So this power n minus 1. So let's take the log of this. So we have log 3.8588 equals to n minus 1 log 1.15. I think I explained that earlier. 1.15. When you take log of this will start at the product of the log of 1.15. So our answer will be log 3.8588 over log 1.15 equals to n minus 1. So what is the division of this one? If I divide log 3.8, so we say log of divided by log of 1.15. That will give me, so everything here gave me 9.66. 9.66. Let's not waste our time. Equals to n minus 1. So n is equals to 9.66 plus 1. N will be equals to what? N will be equals to 10.66. So approximately 11 years. It should be equals to that. 11 years. So that's what that means. 11 years. So we have that already. So as you can see, I think we have the same thing exactly. We have same rate of increment. So we have same thing already. So I think we are good. Alright. That's one form now to the key aspect of finance in full. Yes, gross law enterprises purchase a machine for 930,000, which is the will last for 25 years. So that is, if the machine has a current value of 65,000, that is what the last term, which is a particular term. How much will the machine? How much will price for the machine each year? If the share is on a straight line or basis. If it's on a straight line basis, then we are talking about AP, and we're looking for common or common difference. Yeah. So this is what I will do here. Because of the machine will be the first term. Sorry? Together, it will be the first term. And in the first term, the machine will not in one way or the other be This will not be depreciated. Yeah. So actually we have, what did we have? The first time is actually 930. And the decision is not coming up until the end of that year. So then we are saying it's not coming up at all. So our end in that case will be 26, not 25. Because it's occurring at the last year. So you must always add one, is that okay, to the period. Our scrap value now is not the TN, which is the last term. And that is 65, like T25. The value of the asset at the end of the year is 6025, which is like 26. So what should be provided for annual depreciation? So that will be common difference. So AP now, if it's on a straight line, so that is AP on a straight line. How will Tn equals to A plus n minus 1 times Z. So the value of the Tn at 25 is 65, and the T26 last year equals to 930,000 but plus 26 minus 1, actually you add 1 times T. That D we do not know. So we have 65,000 minus, so we bring this one here, minus 930,000 equals to 25 D. And here will be what? If I subtract 930 from 65, that will be negative what? 65 minus 930. That will be minus 865,000 equals to 25 D. So D is equal to what? Minus 865,000 over 25. So D will be negative because it's depreciation. So it's falling. So divided by 25. So it's 27,800. So annual depreciation charge is 27,800. If it's on the straight line, what increases? If it's now, what will be the depreciation rate? If it's now on what? On the reducing balance. So we refer to what? To GP. So if it is, let's use the data board. So in the second question, we are using GP. The depreciation rate now we get actual what? GP. So since it's on what? On the reducing balance. So we say our N, A is 3 and 930, N is what? 26. So Tn is equals to AR n minus 1. So our Tn at 25 last year is 65,000 last term. First term is 930.